I don't know, man. This is gonna be the most scuffed video I think I've made to date. I may have f***ed up. Hey everybody, and welcome back to the channel. This week, we're gonna be talking about code. So I've made a few edits since the last few videos have come out. I don't really have a structure for how I want this video to go, so we're just gonna kinda go over those edits, look at the code, and you guys can see exactly what I've changed, why I've changed it, and we can have more of a relaxed feel to this episode. Before we get into it, if you guys haven't already, please consider commenting or subscribing or liking the video if you like the video. Be genuine. I really enjoy seeing comments from people, especially comments that are critiquing my code. By no means am I a C++ developer. And so I've had a few comments over the last couple of videos that have offered insight into things that I've missed or better ways to approach problems. And I really appreciate input like that. So if you guys have anything like that, if you just want to say you're enjoying the video series, any of that, please let me know in the comments. Click the subscribe button if you want to see more of this type of content, and let's jump right in. Okay, so before we talk about the actual code, I want to talk about improvements that I've made to my workflow as a developer in general. I don't just do code for the Game Engine series, I'm also a full-time engineer at a company. So anytime that I find some sort of technology that I think could be an improvement to my workflow, I try and incorporate it at least for a short period of time to see if I like it. A few months ago, I changed my keyboard layout and also built a custom split keyboard. I also have swapped, you guys may have noticed, to using NeoVim instead of VS Code. I made that switch a month or two ago as well. And then recently, I've incorporated tmux into my workflow. So that's actually what I've got going on right here. I have this upper pane in tmux that has nvim running, and then this lower pane here is just a terminal. And I've got it configured so that I can move between them freely if I were to open a file and, let's say, open another file. Well, I'm actually writing, oops. Let's do that and move it here. Then I can move freely in between all of these panes seamlessly. If you guys are interested in that, let me know. I can definitely do a video on my environment configuration. So, basically the only thing that I haven't touched since the last few videos is the platform independence layer. I'm really happy with how that turned out. I don't have any plans to change it in the near future. But anyway, so let's start out with our initialization code. So I moved a lot of code away from the header file and into an actual CPP file. I started reading up on things being defined multiple times because of how they're being imported, and in order to avoid that, I moved a lot of code away from headers. But so if I'm here, you can see that I've got all of the initialization code has been moved to this C++ file. Everything is exactly the same as it was, it's just here now instead of in the header file. And I've also added a few new things that we're going to go over here in a minute, like a heap allocator, and the input system is working properly now. But you can see everything else is still happening in the exact same way. There's just a bit more going on, and it's happening in a different place now. Moving on to subsystems, I did end up changing those in that I removed the subsystem base class. I realized that not only was it not providing what I wanted it to, which was essentially creating a contract that a subsystem has a certain set of functions, which technically it was doing that, but it was also severely limiting what I could do with those functions. So what I've done here instead is, instead of having an init function that takes no arguments and then having a separate function I have to call later for creating a window, in this case, the init function will also create the window here, and so it's taking the argument for the window props. And so by doing this in the init function itself, I can essentially define dependencies between different systems. There was a specific user and good friend of mine that pointed that out to me in my systems video, that currently there wasn't really any way to define inter-system dependencies, and so this is now doing that. So while we're here, if we look at the input system, then we can see that it takes a window pointer. And so in the actual initialization code, if we take a look at that, the input system here, when we call init, we provide the window system get window pointer function, or rather the return value from that function. Now I do have the input system being initialized in a different way from the Windows system, which is that it has a getInstance function that is going to return a single static instance, and anytime anyone needs to reference that instance, they'll always get the same one. The reason for that is the input system internally is keeping a map of all of the different key states, mouse button states, the mouse position, all of those things. Those are internally managed by the input system. And so what I don't want to do is try and grab a separate instance of the input system that doesn't have all of that data set. I want to make sure I'm only using one version of the input system throughout the entire engine, throughout the game, all of those things. So the way I have this set up is currently a little janky. I really hate using that word to describe my code, but it kinda is. I definitely am gonna think about how I want to refactor this in the future. But basically I have the input system. The input system has the init and the cleanup functions, and it has methods for updating its internal state that are publicly available to the rest of the engine. They are not, however, available to users that are importing the library. That's the point of that not exported symbol there. And then I have the API symbol, means that it's going to be available to users that are importing, or rather applications that are importing the library. And so I have an input class that has only static methods. It doesn't have a constructor or a destructor or anything like that. So all this input class does with its static methods is it grabs the instance of the input system and then calls the corresponding public function for whatever it is that it's trying to do. So here we're in the actual input system implementation, and then lower down you'll see we have the actual input static methods, and for each of these it's just getting the instance of the input system and then calling the relevant function afterward. I have that set up. I may create a secondary video for the input system to go into it in a bit more detail in the future, but for now that is input. So when we're talking about memory allocation. There are a few changes that I've made to the existing allocators, and I've also added a new allocator. But I think the most significant change that I've made to how these work is including a byte alignment function. So the reason that this is necessary is that on most computers that are aligned to 32 or 64-bit systems, that is the size of the register that is inside the CPU where data is being stored in the fastest version of the cache that is being accessed very, very frequently and very quickly by the computer. When we're aligning bytes, we want to match the number of bytes that we're allocating to that 32 or 64-bit or whatever register size. So the way that I'm doing that here is using the size T type, and that type should theoretically default to whatever the size of a single register is going to be. So on 32-bit systems, size T is going to be a 32-bit integer, and on 64-bit systems, it's going to be a 64-bit integer. When I give it a number of bytes I want to allocate, it's going to expand that number so that it's a multiple of the size of the register. And so this is going to ensure that when I'm allocating memory, I'm allocating a full register, and it's not going to get partial data that's being carried over from the next place where data is trying to be allocated. We also have a new allocator, and this is a heap allocator, which is the most generic type of allocator that there is, I think. Honestly, this one was the hardest one to implement out of all of the allocators thus far. The heap allocator, just like the other two allocators, has an alloc and free method. It also has a constructor where you give it the number of bytes for the heap itself. In the alloc and free methods, all I'm doing is adjusting my allocations here. So this map is keeping track of pointers, and then there is this memory struct up here, and this memory struct keeps track of how big of a chunk of memory has been allocated at a given pointer. So I have the heap, I've got the size, which is just the size of the heap, and then a map of allocations that use the void pointers as their keys. And then I have this find available slot method. So if we're looking into the allocator, first there's in the find available slot method, because everything else is pretty much reliant on this. First, if there are no current allocations, then we can safely assume the beginning of the heap is a valid place to allocate memory. So we're just going to return that. That's just an early exit on that edge case. Then we go through an iterator of all of our allocations, and while we are still reading, we basically grab the memory chunks at I and at the next iteration of I. So we're checking to see if d.start minus c.end, those are both pointer addresses, is big enough to accommodate an allocation of the size that we're trying to allocate. And if that is the case, then we're going to return this, right? And if we make it all the way through the loop and we don't hit this exit to return, that means that we are out of memory in this heap, and we're going to return a null pointer, which is going to cause a segfault for being out of memory. But that's currently intended. I'm not 100% sure how I really want to handle that, or how big of an issue it's even going to be, right? But for now, that's how I'm going to handle it. I will probably revisit that later. And that's it for the heap allocator. All right, that's going to be it for this video. Once again, if you guys enjoyed this video, please like or leave a comment, or if you want to see more stuff like this, then hit the subscribe button. I'm trying to put out videos every week right now. We'll see how long I can keep that up. But in the meantime, if you guys have any questions for me or anything like that, then you can actually join a new Discord server that I've started. I've got the link down in the description below. Please check it out if you guys are interested in haranguing me about my terrible, terrible code. Anyway, I will see you next time. Bye.